Welcome to the simplified example of how plate tectonics leads to earthquakes. In this example, we're going to be using water, graham crackers, and icing. With plate tectonics, you need to remember that there are two main layers. You have the lithosphere, which is on the top, and the asthenosphere. With this, we'll start with the icing. The icing is going to be our asthenosphere. Because the asthenosphere is a solid, much like icing, that acts like a liquid, once again, like icing. With this, you have the asthenosphere and the lithosphere being on top. Those are the plates. Make sure you have no icing dripping all over. With this, you have the plate right here. Where these plates meet, that is known as a plate boundary. In this example, I'm going to dip one of these graham crackers in water to help us. So, there are three main plate boundaries. You have convergent, divergent, and transform. With transform, you have quite a bit of earthquakes. They're not that strong, but you have a lot. This is kind of like California, where the plates move side to side. Where they're meeting up only a little bit. You have earthquakes, of course, you have a lot of them, but none that are that true power. With divergent, you have these splitting apart, where the two, you just have nothing in the middle. Well, that's where magma comes into play, but that magma does not create earthquakes. So the plate boundary we really want to look at is convergent, where these two plate boundaries come together and meet. With this, you have the two coming together, and you have what is known as folding and faulting, where you have one going on top of the other. Remember, it's called the subduction zone. With this, you have breaks along the side. Those are known as fractures. Those fractures, when in a straight line, create something known as a fault line. Now, with that, where those two cracks of the plate boundaries are meeting up and they are being released, that energy that's being released is in the form of an earthquake, because there is a lot of energy, because you have a plate the size of, say, North America or Europe and Asia together. It is a huge amount of energy, and that's from these small fractures at the very beginning. Once they start getting bigger and bigger, the more energy that is being released.